Hello, algebra students. Today's lesson is on solving absolute value equations. Now, this is a little bit trickier of a topic, so feel free as you're watching the video to pause, write stuff down, maybe try some examples yourself, and then check it to see if you got it right. Or just rewind, watch it again. Take a minute to let it sink in. All right, so something you hopefully learned in previous grades is that absolute value is the distance from zero. Because it's the distance from zero, the absolute value of a number is always going to be positive. If we're looking at our core concepts, the first one, it says the absolute value of a being a real number, is greater than or equal to 0. That means it's either going to be 0 or it's going to be positive. It's going to be greater than 0. All right, our second core concept is that the absolute value of a negative number is the same thing as the absolute value of its opposite. So this would be the absolute value of -2 is equal to the absolute value of +2, because the distance between -2 and 0 is the same as the distance between 2 and 0, would both be 2. All right, the absolute value of two numbers multiplying, or the product of two numbers, is equal to the absolute value of the first number times the absolute value of the second number. And the absolute value of a quotient, or the absolute value of two numbers divided by each other, is the same thing as the absolute value of the numerator divided by the absolute value of the denominator, as long as the denominator, or the number you're dividing by, is not 0. All right, so solving absolute value equations. To solve for an equation is equal to a number, we're actually going to split it into two equations, because what's inside the absolute value could be positive or negative. So we're going to set an equation where it's what's inside the absolute value is equal to the positive answer, or what's inside the absolute value is equal to the negative answer. Now, this may seem confusing right now, but we're going to go over some examples, and hopefully it makes more sense then. If, just a little note at the bottom here, right here, if you have an absolute value that is equal to a negative number, it has no solution. So if in that case the absolute value ax plus b equals a negative c, it's no solution, it doesn't work, because you can't have an absolute value equal to a negative. All right, so our first example, we have the absolute value of x minus 4 equals 6. So what's inside that absolute value could be either 6 or -6, because I know that the absolute value of -6 is equal to 6. So I'm going to start by setting up two equations. My first equation is just going to be x minus 4 equals 6. And then my second equation is going to be x minus 4 equals -6. All right, I have my two equations set up. Now I can solve for x. So to solve for the variable, we get the variable by itself. To undo the subtraction, I'm going to add 4 to both sides. They cancel out on the left, and I have x equals 10. And I'm going to solve for the x in the second equation, so add 4 to both sides. They cancel out on the left, and I have x equals -6 plus 4, which is -2. And those are my two answers. So in most normal cases, absolute value equations will have two solutions. All right, let's try the second one. I have 3x plus 1 equals -5. Well, the absolute value is equal to a negative, which is impossible. So this one has no solution. All right, a key point in today's lesson. So when we have a multi-step equation for absolute value, key point, absolute value is a grouping symbol. So think of GEMDAs. The G stands for grouping symbol. That means when we're solving, when we're using inverse operations, the grouping symbol gets undone last. So we have to undo all other operations before solving the absolute value. Meaning I'm just going to have an absolute value equal to a number, a positive number, or it's no solution. All right, so let's look at example A. I have the absolute value of 3x plus 9 in the absolute value, minus 10 equals -4. So I need to get that grouping symbol, the absolute value, by itself. So the first thing I'm going to do to this equation is add 10 to both sides. Remember, if we do one thing to one side, we have to do it to the other side. So it's going to cancel out on the left, and now I have the absolute value of 3x plus 9 equals negative 4 plus 10, which is 6. All right, now I have just the absolute value in a number, so from here I'm going to set up two equations. So I could have either 3x plus 9 equals 6, or I could have 3x plus 9 equals negative 6. All right, now I'm going to solve for x. So subtract 9 from both sides. I have 3x equals negative 3. And divide both sides by 3. I get x equals negative 1. And on this side, take away 9. I have 3x equals negative 15. Divide both sides by 3. I get x equals negative 5. All right, I encourage you to pause the video now, copy down each step, make sure each step makes sense to you. Otherwise, write down a question, ask it when you come back to class. All right, so part B, I have 4 times the absolute value of 2x plus 7 equals 16. I have to get that absolute value by itself, so the first thing I'm going to do is divide by 4. Divide both sides by 4, so now I have the absolute value of 2x plus 7 equals 16 divided by 4, which is 4. Now I have just an absolute value is equal to a number, so I'm going to set up two equations. 2x plus 7 equals 4, or 2x plus 7 equals negative 4. All right, now we can solve by x, or solve for x. So first thing I'm going to do is subtract 7 from both sides. I'm left with 2x equals 4 minus 7, which is negative 3. Divide both sides by 2, and x equals negative 3 halves, or 3 divided by 2, or negative 1.5, however you decide to write that. All right, and in the second equation, subtract 7 from both sides. I have 2x equals negative 4 minus 7 is negative 11. Divide both sides by 2. I have x equals negative 11 halves, or negative 5.5. All right, I encourage you to pause the video at this part and see if you can solve for C all by yourself, and then press play again to check if you got your answer right. All right, so part C, we need to get the absolute value by itself, but there's not just one other operation, there are two other operations. I see a subtraction and I see a multiplication. So first thing we're gonna do is get rid of that subtraction. So we're gonna add 3 to both sides. And now I have negative 2 times the absolute value of 5x minus 1 equals negative 11 plus 3, so it's going to get closer to 0 and be negative 8. Now I need to divide by negative 2, so divide by negative 2, divide by negative 2. Now I have the absolute value of 5x minus 1 equals negative 8 divided by negative 2, positive 4. Negative divided by a negative is a positive. All right, now I have just an absolute value equals a number, so now I can set two equations up. So I have 5x minus 1 equals 4, or 5x minus 1 could equal negative 4, because the absolute value of negative 4 is positive 4. All right, now I solve for x, so I'm going to add 1 to both sides. Cancels out on the left. I'm left with 5x equals 4 plus 1, which is 5. Divide both sides by 5, and I get x equals 1. All right, solving for the second equation, I add 1 to both sides. Cancels out on the left. I have 5x equals negative 4 plus 1 is negative 3. Now I divide by 5, and I get x equals negative 3/5. All right, last example for this section. What do you do if there's an absolute value on both sides of the equation? Well, you're going to set it up as though both sides is positive, or you're going to set one side negative. So to solve the absolute value of ax plus b equals the absolute value of cx plus d, you're setting up two equations again. One equation where both sides are positive, and one equation where one whole side is negative. You could make both sides negative, but that would be the same thing as if they were both positive. So either both positive or one side negative. All right, let's look at example A. We have the absolute value of 3x minus 4 equals the absolute value of x. So what do you think the two equations are going to be? We're going to have one equation where both sides are positive, so just the way it's written inside the absolute value. Or we're going to have one whole side negative. It should be a multiplication, not a subtraction. Okay, so the other equation is going to be 3x minus 4 equals negative x. All right, and then we just solve for the variable. So I have 3x minus 4 equals x. I'm going to get all my variable terms to one side. So subtract 3x from both sides. I'm left with negative 4 equals x, 1x minus 3x. 1 minus 3 is negative 2, so I have negative 2x. Now I divide by negative 2. Negative 4 divided by negative 2 is positive 2 equals x. X equals 2. All right, in the other solution, if I subtract 3x from both sides, cancels out on the left. I'm left with negative 4 equals negative 1x minus 3x, or negative 4x. Divide both sides by negative 4. And I get 1 equals x. X equals 1. So those are my two solutions to that equation. All right, second example, I have the absolute value of 4x minus 10 equals the absolute, or equals 2 times the absolute value of 3x plus 1. So I'm going to do one equation where both sides are positive. 4x minus 10 equals 2, 3x plus 1. Now, because this is a positive 2, I don't have to worry about whether or not there's a solution. If that were negative 2, you can't have the absolute value equals a negative, so then it would be no solution. But you can have a negative inside an absolute value. So the second equation we're going to set up, we are actually going to make that 2 negative instead of just multiplying by negative 1 as well. So negative 2 times 3x plus 1. All right, let's look at the left one first. I see a 2 outside of parentheses. Instinct is to distribute that. So I have 4x minus 10 equals 2 times 3x is 6x. 2 times 1 is 2. All right, now I want to get all of my variable terms to one side. So I'm going to subtract 4x. Cancels out on the left. I'm left with negative 10 equals 6 minus 4. 6x minus 4x is 2x. So I have 2x plus 2. Now I'll get all my constant terms to one side. So subtract 2, cancels out on the right. Negative 10 minus 2 is negative 12. So I have negative 12 equals 2x. Last step, we're going to divide both sides by 2. And I get x equals negative 6. All right, so that's one solution. The other solution, still going to distribute the 2 first, but I have to be really careful when I'm distributing negatives. Negative 2 times 3x is negative 6x. Now, the part that a lot of people forget is that you have to distribute the negative to the second part as well. So negative 2 times 1 is negative 2. So that's negative 6x minus 2. All right, so we're going to subtract 4x from both sides again. Cancels out on the left. I'm left with negative 10 equals negative 6x minus 4x is negative 10x minus 2. And then we get all our constant terms to one side, so add 2 to both sides. Cancels out on the right. Negative 10 plus 2 is negative 8. So I have negative 8 equals negative 10x. Last step, we're going to divide by negative 10. And I get x equals 8/10, which you could write as a decimal, or you could also say 4/5. and that should be positive because a negative divided by a negative is a positive. All right, let's wrap up 1.4 with some summary questions. First question, why do you need to write two related equations when you solve an absolute value equation? Well, because what's inside an absolute value could be positive or it could be negative. So we need to write both the positive equation and the negative equation to get that absolute value answer. How do you graph the equations to an absolute value equation? We're actually gonna skip that one because chapter 2 will cover graphing. What does it mean when there's no solution for an absolute value? That would be if you have an absolute value is equal to a negative. Because absolute value is the distance from 0, it's always going to be positive. If it's equal to a negative answer, it is not true. It does not have a solution. All right, last one. How do you solve the equation 2 times the absolute value of x plus 7 equals 6? Well, we learned that absolute value is a grouping symbol. So you would have to divide both sides by 2 first and get the absolute value by itself. Then you can solve the absolute value for x by setting up two equations, one positive, one negative.